Hello everyone, this is Professor Kuehn. We've been discussing Chapter 3 in A Student's Guide to the Great Physics texts, in which Galileo is talking about the speed of falling objects and how that relates to the weight of the object and the density of the medium through which it falls. In the last lecture, I talked about how an object can be neutrally buoyant. We talked about a ball of wax and how by pressing grains of sand into it, one can make the density of the wax equal to the density of water. We can make the specific gravity of the wax and sand combination equal to 1. At this point in the dialogues, right around page 37, there's a short discussion on surface tension. This is not the term that Galileo uses, and it's the modern term, but what really Galileo is talking about here is what we now refer to as surface tension. I would love to give a very long lecture about this, talk about this in a lot of detail, but for the sake of time, I'm going to keep this fairly brief. Briefly, Galileo believes that water does not exhibit any internal coherence. That is, if you try to break water apart, it doesn't have any sticky bonding forces that hold it together. That's Galileo's view. Of course, water is hard to break because nature abhors a vacuum, but there's nothing beyond that. There's no internal bonding that holds water together, according to Galileo. This is actually incorrect. Galileo is incorrect about a number of things, but this is one of the things that I like to highlight he's not quite right about. He was aware, and this is interesting in this dialogue, he's aware that some surfaces attract and other surfaces repel water. He talks about how if you put a drop of water on a cabbage leaf, the water kind of balls up into a little droplet, and he says that's because cabbage leaves repel water. And on the other hand, if you put a drop of water on a plate of glass, the water spreads out because the glass attracts water. So it's really, in Galileo's perspective, the relationship, the effect that this medium that the water is sitting on the water, it has nothing to do with the internal cohesion of water. So that's just one thing I'd like to point out. This is, like I said, right around page 37 in chapter 3. Let me just explain one other aspect of surface tension. This is something that Galileo also brings up. He brings up what is now known as tiers of wine. So you may have noticed, if you have ever had a glass of wine or some kind of other strong liqueur, if you look at the glass very carefully, where the surface of the wine or the liqueur is, it creeps up the side of the glass and it kind of wets the side of the glass, but then it forms these droplets that roll gently back into the wine or into the liqueur. These are called tiers of wine, and I want to spend a minute talking about this because Galileo actually brings this up. So this is now called tiers of wine. And I want to give a brief explanation of this as a way of kind of pointing you in the right direction because Galileo is a little bit perplexed about this phenomenon. So why does wine or other strong alcoholic liqueur creep up the side of a glass? Form droplets and roll back into the glass or into the remainder of the fluid, into this, I guess we might call the standing fluid. Why is that? So that's the question that we're asking. And so let me draw a picture here. So let's suppose this is the cross-sectional view of the glass. Okay, here's the stem of the wine glass. Whoop, it's not very good. Like that. So here's the stem of the wine glass, and here's the glass, and of course this is where the wine is held. And so let's put some wine in here. So the wine is at this level, but you'll notice that it kind of curves up at the edges. Okay, so what's happening here? Well, when you have wine, it's actually a mixture of water and alcohol, right? So let me write a couple of steps here. So step 1 is the water and alcohol. It's a mixture. And that mixture has a low surface tension. Okay, so water actually has a very high surface tension. The surface of the water acts like a membrane that is somewhat difficult to break. That's why water striders or a leaf can sit on the top of the surface of water. So the water has a high surface tension, but when you add alcohol to it, it actually reduces the surface tension. It reduces the surface tension. So you can think of surface tension as a reflection of the internal cohesion of the liquid. It's a reflective of the internal cohesion of the liquid. So what happens is this liquid is, although it's attracted to itself because of this internal cohesion, it's also attracted to the atoms that make up the glass. And because it's a mixture of alcohol and water, the surface tension is reduced, and so it's preferentially attracted to the glass. Preferentially attracted to the glass because of the reduction of the surface tension due to the existence of alcohol, okay? And that implies that it will creep up the side. Okay, so that's what's happening here is this wine-water mixture is kind of creeping up the side right here. And then what happens is in this region right here, what's going on in that region right there? Well, since this is a thin layer right here, as the alcohol evaporates, because alcohol evaporates more readily than water, it's more volatile. So the alcohol evaporates, it's evaporating from everywhere, but it's also evaporating from here. And as the alcohol evaporates from everywhere, what's going to happen is that you're going to get a higher concentration of water in this region, okay? Because it's a thin layer, it has a big surface compared to the volume of water in this little layer. So when a little bit of alcohol evaporates, you have a surplus of water in that region. So as the alcohol evaporates in the film coating the glass, what happens, the water-rich region, this region becomes water-rich. Water-rich, because the alcohol is left. So this region right in here is fairly rich in water. So I'm going to maybe color this a little bit more blue because it becomes more water-rich. Okay? And what happens then, I guess we could call this step 3, when it becomes water-rich, because the alcohol has a lower tendency to bind to itself, it has a lower surface tension than water, what happens is this becomes very cohesive to itself. Okay, so the surface tension increases since the surface tension of water, I guess we'd say of pure water, is greater than that of the water than the H2O alcohol mix. Okay, and when the surface tension increases, then what happens is that it beads up, it forms into balls. So the film coalesces into droplets. And these droplets then roll back into the fluid in the glass. And that's why you get these little tears of these droplets rolling back into the glass. So this is a perspective that we have of the tears of wine. I thought this would be an interesting thing to bring up. The subject of surface tension is really fascinating. Galileo mentions it here. He has a good eye for observing interesting phenomena, and he really, he would be a good graduate school advisor because he points out interesting problems that people would later study and gain a much deeper understanding than Galileo himself had. So let me stop there, and we will next time talk about the speed of falling objects through fluids.